Cisco Certified Network Associate Day 23. Welcome back everybody, I'm Imran Rafai, your trainer for this entire series. Today we're going to learn about routing advanced, which means we're going to learn slightly advanced topics on routing. Right, so let's not waste time. Let's get straight into today's class. But just before that, I've had a lot of students who ask me about my social media platforms, which we have not revealed, or I might have revealed, but I'm going to put everything on one screen. So on the left, what you see is social media channels for networking as a company, and what you see on the right is social media for me, my personal social media contacts. Now, like I've explained earlier, this is my Facebook, where Imran.Rafai is my Facebook ID. I don't accept friend requests on Facebook if I don't know them personally, so please don't send me friend request. But what you could do is you could follow me on Facebook. There is an option called follow, right? So you can follow me on Facebook, where you get all my updates. You could send me requests on LinkedIn, of course, and also give me a recommendation. I would highly appreciate that, because you could recommend me as a trainer or networking. Right, so yes, you can send me friend requests or contact requests on LinkedIn, and I will accept you. And you could, I reply to LinkedIn messages. So if you send me messages on LinkedIn, I try and answer it as soon as possible. I'm also on Twitter, not very active, but of course I'm trying to be more active on Twitter, and that's my Twitter handle. And what you see on the left here is for our company, NetworKing. So you can go to NetworKing Consultant, and please give us a review on NetworKing Consultant on Facebook. You could go there and you will see it. Our logo is going to be there, and you know it is our website, our Facebook channel, and give us reviews on networking. And of course YouTube, the very reason you're watching this on YouTube for free is because of our YouTube channel on it's called NetworKing Inc. So please pause and subscribe to this channel. And of course we have a Twitter handle for networking, which is also we're not very active on there, but we'll try and be more active on Twitter for myself and for the company as well. Right, so these are our social media platforms, and if you want links for it, specific link, look down in the description. I'm going to put links for all these 6 channels on the description below. So yeah, have a look there. Right, so let's not waste time. Let's get straight into today's class. So what are we going to learn today? We're going to learn 3 things, like always. 3 is my favorite number, right? Routing explained, where we will look at routing a little more. We'll look at the routing table components and how routing is done, what are the different types of static routes and things like that. Then we'll look at inter-switch routing, where we will explain how routing happens between 2 switches. Right, and also we'll look at another concept. We learned VLAN, right? So we had in one switch we had multiple VLANs. We'll see how communication can happen between one VLAN to another VLAN, right? It's called inter-VLAN, and so it's a very interesting topic. So this is one video you will have to concentrate a little bit. Maybe you can watch it a couple of times, because it's a very interesting topic. We will look at sub-interfaces and things like that. And of course one more very interesting topic called as router on a stick, right? And if you're wondering why do we have vegetables on a stick, router on a stick, vegetable on a stick, I know, bad joke, but I'm just trying to establish that, right? So let's get straight into today's class, right? What is a routing table, right? So we have learned what a routing table is. A routing table is a table by which devices or routers make routing decisions of where to send packets, right? So this is what typical routing table looks like in a Cisco device, right? Every computer, even your Windows PC, has a routing table, but that's for a different discussion altogether. We are particularly interested in routing tables of a Cisco device or a Cisco router. We know these codes. So R is it signifies that this particular route 192.168.30.0/24 120/1 is learned via the RIP routing protocol. C is directly connected. Again, our RIP routing protocol S is static, right? If you look here, you'll see S for static. Now there is one dot here, that is default, right? Candidate default, you can see it here, candidate default, right? We will learn about what candidate default is. That's here, this part we'll learn, right? That's a different types. We have different types of static routes, so we will see that in this part of the discussion. Now in the routing table, right, let's take this for example, the RIP routing protocol 192.168.30.0/24. And you'll see these two numbers, and we have discussed this earlier, 120 and 1. 120 is the admin distance. Admin distance is the believability or reliability of this route, right? If you had another route with C or S which says 192.168.30.0/24, and it says S which says 1/0, or any number that is smaller than this, let's say 1, right? Static route is 1.1, whatever, right? As a router, what it is going to see is, it's going to see, right, first of all, you will not have two routes until we have load balancing and things like that, which is a total different concept which we will come back later. But let's assume for argument's sake, if you have two thing where the lesser number, right, lesser number is more believable, right, or more trustworthy. So high numbers are less trustworthy. So if let's say you have a static route on this, the static route is what is going to be displayed here, and that is going to have more power, right? So lesser AD means that is more believable. That's what believable is, right? So that is that, and then of course it tells through which interface or which IP address it needs to go out the data, right? So that's the components of the routing table. Now routing decisions. So like I said, if let's say, like in this case, you have a candidate default. Candidate default means everything. If you don't know, if there is, let's say there is a traffic coming to this particular router, there is a traffic coming for 30.1.1.1, right? And you see that 30.1.1.1 is not part of the routing table. So that means this router, ideally, if there's no default route, it says I don't know, and it'll start dropping packet. But if you set a candidate default, right, if you set a candidate default, that means you say that anything that you don't know, send it through the candidate default, right? And it says in this case it has to send out on 192.168.10.1. So every traffic for 30.1.1.1 will go out on this 192.168.10.1 because of this candidate default. Right, but ideally what happens is when there is a traffic request, right, for any IP address, the router will first look at a specific route. So let's say 30.1.1.1, right, /24 is the traffic. The router will first look at 30.1.1.1. Is there a specific route for that particular route, 30.1.1.1? It says no, it's not available. Then it will look if it has a route for the network, 30.1.1.0/24, right? Like in this case, let's take another IP address. 192.168.30.1 is the traffic that is coming in. So if a traffic comes into this router is going to look for that particular IP address, 192.168.30.1. Now if 30.1 is not available, then it will look at the network, 192.168.30.0/24. This is the whole network that includes 192.168.30.1, right? So it will make use of this route and send the traffic on that route. If even that is not available, then it is going to look at the default route and send the traffic on the default route. So that's how routing decisions are made. First is specific, then network, and then it is going to go into a default network, right? So that's what. Next, let's look at static routes. There are different types of static routes. The first one is the default route, like we already discussed. Default route is a route that you give where you tell the router that if you don't know about any route, please send it on this default route. That's your last resort, right? So if you see here, it says the gateway of last resort is 192.168.10.0 to network 0.0.0, which is nothing but telling that the default route is set, like in this case, right? So that's the last resort. If nothing matches, this is where you need to send the traffic out on, right? So how do you do that? It's the same, the format is the same. You type in the global configuration, you type IP route, and then if you remember from our static route video, which we learned I think a couple of videos earlier, you give the network ID 192.168 right 30.0, like in this case, let's say you see this rep routing, right, 192.168.30.0/24. so you give IP route 192.168.30.0 255.255.255.0, and then you give the IP address 192.168.20.1, like in this case, this is the next hop, right? That's how you set a static route. But if you want to set a default route, you don't give a network and subnet mask. What you give is IP route 0.0.0.0 4 times, and again for subnet mask you again give 0.0.0.0, and then you give the next hop IP address, which is 192.168.20.1, and which will make that the default route, right? So that's how default routes are done, which tells the device what is the last resort route to take. Next we do is a network route, right? Network route is the same thing. 192, again what you're doing is you're giving the entire network, like in this case 192.168.30.0, right? So it says, so if you want to set up, it is IP route 192.168.30.0, and then you say 255.255.255.0. that means it's a /24. You're telling this whole 24 network. That means there are 256 possible IP addresses that range, and tell the next resort next IP address, right? Next hop IP address. That's how you set the network route. Right, something's happened. I have this new tablet. It just changes. I don't know, it's very sensitive, and I'm still getting used to this new tablet. I think it's just jumping pages, and I think I've lost some scribbles, but don't worry, you understood the concept, right? So default route, I'm gonna just write here the format just to be thing. So it is IP route. This is the command, IP route, and then you give the first part, the second part, and your next hop IP, right? This is the next hop IP. That's one IP address. So if you're doing a default route, you put 0.0.0 here, that's 4 zeros, and the subnet mask is also 0.0.0. If you're doing network route, you're giving the first part as the network ID, right? You remember network ID from our IP address subnetting videos. So you give the network ID. So let's assume this 192.168.30.0, that's a network ID, and then you give the subnet mask of 255.255.255.0, which is /24, and you give the next hop IP address, whichever you want to give in your routing decisions, right? So that's for network route. If you want host route, remember you need to give the host IP address. Remember what I said, specific route. So that's how you give that specific route. That will be 192.168.30.1. I'm talking about that one particular host, right? And then you give the subnet mask, and in this case, remember it has to be a /32. That is 255.255.255.255. That means you are matching the entire IP address. You're not saying anything is, you're not telling something is host and something is network, right? In this case, it's that one particular IP address, and then you give the next hop IP address, and that's how you set the host route. Summary route, if you remember summarization or supernetting, right, where you have a range of IP addresses, right, and let's say for instance in this case 192.168.30.0/24. this, I mean, let's assume there's a router here, right, R1, and this side you only have 4 IP addresses, 192.168, 30.4, 30.5, 30.6, and 30.7. You only have 4 IP addresses here of that range, right? 192.168, 30.0/24. So /24 has how many IP addresses? 256, but only 4 IP addresses are here. Now if I give a routing in this route, I tell 192.168.30.0/24 send all the traffic going there on this route or this interface. That's like telling a lie. Remember, 192.168.30.1 is not available here. Maybe 30.1 is available on this interface. So we can't give 192.168.30.0 on this interface because it is wrong, right? So we need to summarize. We need to say what IP address or what summarization network will inculcate these 4 IP addresses. So let's be slightly we're going back to our summarization video. We have already done this, but I'm just going to try to see if I can concisely put it here. 192.168.30.4, 30.5, 30.6, 30.7, right? So we see that only these 4 IP addresses are available on this interface, and let's say all the other IP addresses are available on this interface. So if I put a route which says 192.168.30.0/24 is available on this interface, it is all wrong, because if it is 30.1, that needs to send traffic here. Only for these 4 IP addresses, it needs to send traffic out on this interface, right? This interface is only for these 4 IP addresses, and this interface is for all the IP addresses in this range of 30 dot, right? That is where we need to do a summary route. So what you need to do is you need to find out a mask, right? Or find out if you remember our subnetting thing, we see, if you do summarization, we can see that this doesn't change. 192.168.30 doesn't change. So up to 24 it doesn't change. So we need to get one subnet which has all these 4 IP addresses. So if I would say go back to our summarization video, it is going to explain slightly more, but I will tell you this IP address 192.168.30.4 slash, what's the number, 252. 192.168.30.4/252 is a summarization IP address. If you do subnetting, you will see that the subnet 192.168.30.4/252 will have 4. It's a block of 4. The 4 blocks are 30.4, 30.5, 30.6, and 30.7. So in our summary route, we will say IP route 192.168 30.4 255 255 255. Sorry, this is not /24 /252. It's subnet mask has 252 in the 4th octet, so it'll be /30, right? So we'll give 192.168.30.4 and 255 255 255.252, and then you give the next hop IP address, which will tell that. So in the routing table, you will see that you will have 2. Let's say you have this network route which says 30.0/24, and then you have a summary route of 30.4/252 /30. Then all the IP address for this range will use a summary route as the routing, because it's more specific, right? If you remember, and everything else that is not part of this summary route will take the network route, right? You remember? So that's what summary route is. You summarizing that IP address or the range of IP address that's available and putting a route. Then we have something called the floating route. Floating route is a backup route, right? Sometimes you have physical layer disconnection. Let's say you have a static route. Like we said, static route will always have an AD of 1, right? If you don't want, let's say if you want a backup route in case there is a problem with the static route, let's say this in network 192.168.10.1 physical layer gets disconnected, and what happens then? So we need to give us a backup route. So we will give same thing 0/0 or whatever static route, and you will give the AD as another AD. If you don't give any AD in your static route here in this IP route format that you see on top, if you don't give anything at the end, by default it takes a AD of 1. But if you want a different AD, you just, after you put the next hop IP address, you give the AD value. Let's say you say 5, it becomes 5. So that means there is going to be another route, same thing, at AD of 5, which will not come in your routing table, but that's going to be your backup route, and this is called as a floating route. That route is a backup route that's there in your routing table. It will come into play only if your static route or your primary route goes off, right? That's a floating route. So a lot of concepts that we learned. I know it's slightly confusing. I'm trying to pack in a lot of things, but if you're confused, just watch it once again and you will get it clear. But if you have any doubts, you can always send me an email and we will clear, right? Right, so how do you do inter-switch routing? So we discussed this. So you have, let's say on the left, what do we have? Colored in blue is a switch that is only for sales department, and on the right we have another switch which is only for marketing department, right? This is how you would do if you don't have VLANs. You would keep separate switches. That means sales department and marketing department can't access each other's computers because they're totally independent switches. There's no connection. If you want to have connection between those two, you would use a router. Router will route packets between two networks, right? This is one network, the 192.168.1.0 network, and this is the 192.168.2.0, and both are /24 networks, right? So these two networks can route packets through the help of a router, right? The router R1 in this case. And of course, if they want to access the internet, of course they'll come to R1, and then the router will route the packet to the internet. That's how it is done. There's no direct way of connection. If you just take a wire from this router, this switch and this switch, they will not communicate because they're in different I mean, if you don't do any VLAN, if both of them are part of VLAN, if this is also VLAN on this switch and this is also VLAN on this switch, then of course they will start communicating with each other. But because the IP addresses don't match, they will technically won't be able to communicate, but they're all part of the same broadcast domain, right? And that's not right. And also, let's say if you only, let's say the switch is a 16 port switch, right? And this is also a 16 port switch, and we're wasting a lot of ports. If you, let's say you only have 2 computers, you're wasting almost 14 ports, right? And in this case also you're wasting 14 ports because you only have 2 computers. Ideal way, like we discussed, is what we use a VLAN, right? We use VLAN, and then the blues are in VLAN, let's say 10, and the greens are in VLAN 20. And what happens? So basically now the blues will all remain in VLAN 10, so they have their own broadcast domain, and the greens will all remain in their own VLAN, which is VLAN 20, and they will have their own broadcast domain. How do we do inter-VLAN routing? You would think from one of a green port or VLAN 20 port, and from another wire from VLAN 10 port. So take one wire from VLAN 10 port, connect to the router, take another wire from VLAN 20 port and connect it to the other interface of the router, and communicate. Brilliant solution, which is a very natural way of thinking. You can do that. There's nothing that is wrong about that, but that is wasting. I mean, in a router, real estate of ports are very, very limited. You know, you only have so many ports in a router, so you're not going to waste a port, right? There is a better solution that is known as router on a stick. So what you do is make one port on the switch as a trunk, connect that as a trunk to the router. Now, like we discussed, router by default does not understand the encapsulation of .1q, which is used by trunks. So we need to do something else and create a way to tell the router trunking protocols, right? Encapsulation, right? So we would do something known as sub interfaces. We'll look at that, but this concept is known as router on a stick. So what basically it does is the blue port or the VLAN 10 sends traffic to an IP address here, right? Because if you don't have sub interfaces, this port can have only one IP address. What will it be? Will it be 192.168.1.0/24 range, or will it be from the 192.168.2.0/interface range, right? So you see the confusion. You cannot have, because they're different networks, you need to have 2 different IP addresses. So we will create sub interfaces. One interfaces would be broken down into 2 interfaces, and we will give VLAN 10 and VLAN 20 to both of them. So one sub interface will have VLAN 10, another sub interface will have VLAN 20, and we'll give IP addresses from this range for VLAN 20 and IP address from this range for VLAN 10. So when this device sends out packet, the gateway will be the VLAN 10 IP address here, and when this marketing sends out packet, VLAN 20 will be the gateway, and they will send, and this router will take those two and route between these two devices or these two networks, right? We look at that using packet tracer. All right, so I have configured a packet tracer environment where PC0 represents a sales network which has IP address 192.168.1.10. PC2 has an IP address 192.168.2.10, right? So I'm just going to quickly go check. IP address 192.168.1.10 is assigned to PC0, and PC1 has an IP address 192.168.2.10, right? That's all done. I've not done any more configuration. So this is a switch. So what we're going to do is we're going to put this interface in VLAN 10. This is VLAN 20, and we'll make this as a trunk, right? I mean, before we do that, we'll try communicating. It will not communicate, and then we will try getting it sorted out. We go here, right? Show IP interface brief. We see that 02 and 03 is up, which means these two are where our computers are connected. We will also look at we'll also show VLAN database. So we look at VLAN database. We see that, okay, I'm gonna just make this big. We see that all the VLANs are part of the what is that, default VLAN, that is VLAN 1. So let's go there. So config t interface f0/1, or rather 0/2, that is the sales VLAN. So we will say switch port mode access. By default it is in access mode, so we can know nothing is changing, but we're just typing that switch port access VLAN 10, right? It'll create a VLAN because there's no VLAN 10. If you see here, VLAN 10 did not exist, but they're going to create a VLAN 10, right? Right, so VLAN 10 is created, and this port has gone into VLAN 10. Then interface f0/, I'm going to also show you how VLAN is done. We have done this. So if you want to create explicitly, in this case VLAN was not this, so it created a VLAN, but explicitly if you want to create a VLAN, you just say VLAN 20. Now if you see, we have gone into the VLAN subcommand. This is where we can change the VLAN. So we can say name marketing, right? Then interface f0/3, switch port mode access, switch port access VLAN 20. In this case, it did not tell it is creating VLAN because we had already created the VLAN before we did this command. And I mean, whatever way you want, you can do. If you do the second way, it's just that you have additional ways. I mean, you can now, I mean, when you're creating the VLAN itself, you can start doing the naming thing and all those things. It's not that you can't do on VLAN 10. Of course, we can do the same thing with VLAN 10. All you have to do is come back to your global config and say VLAN 10. Now you go back to VLAN 10, and you can say name here, and you can say sales. But I want to show you what happens if you don't do it. What is the default way? So VLAN 10, if you can see, it has a default name of VLAN 0010, but VLAN 20 we had to manually go and we created the other way, so I could name it, right? So if you want to name it, it's not that you can't. Of course, like I said, you can come back to VLAN 10. We came into VLAN 10 for global config, and here I can say name sales. Everything is possible. So now if you say show VLAN, you will see that VLAN 10 is named as sales and VLAN 20 is named as marketing, right? So that's fine. And then f0/2 is in VLAN 10, and this is in VLAN 20. And what happens now if you go back here? Can this device communicate with that device? Right? Ping 192.168.2.10. Can you? Of course you can't, because this is going to send an ARP to VLAN 10. This switch has only one VLAN 10, so that broadcast is not going to go anywhere. It's just going to stay there, and it's saying who is VLAN 192.168. I mean, first of all, this is 1.10, so it says, okay, I need to send this out to my gateway. who is the gateway? 192.168.1.1. So it's going to send an ARP asking who is 192.168.1.1 to this switch. ARP is a broadcast, but this switch has only one interface in this VLAN. That means it's not going to go out anywhere. It's just going to come to this interface and it's going to die there. So you will not get a reply, and that's what happened here. If you go here and check what happened to our ping timed out because it came asking for an ARP. ARP failed. ARP was dropped because there's nobody in that VLAN. There's only one interface in that VLAN, and 4 times it sent out request and it timed out. There was no reply coming out. So it will not work. So how can you make it work? So even if, let's say, they were part of the same VLAN, it would still not work because they are different IP addresses, right? So to make this work, we need to make use of a router, right? I'm going to show something different. So before we do the thing, I will show you what is that thing. When I was studying, what I thought when my teacher asked me this question, I gave a very unique answer. Maybe it's a long shot, but I'm gonna do that. Let's see. It's fun. Let's first do this. I'm gonna put one wire to the router. This is F0/1, and I'm gonna put another wire that is F0/4, right? Okay, brilliant. So where did it go here? G0/1 and G0/2. Which went to G0/0/0, and this is 0/1. Brilliant, perfect. So I'm gonna put these 04 into VLAN 10, right? Interesting. Interface F0/1, switch port access VLAN 10, interface F0/4, switch port access VLAN 20. Right, so basically what I've done is I've put, like if you do here, show VLAN, you will see that sales has got 0/1 and 0/2, and 0/3 and 0/4 is in marketing, right? Now we'll come back here. Now we'll go to the router, and we will do right, sorry about that. Right, so we'll go into interface G0/0 and give an IP address of first we'll do no shot, and then give an IP address of 192.168. So IP address 192.168.1.1.255.255.255.0. Similar thing, we'll do interface G0/1 no shot, IP address 192.168.2.1.255.255.255.0, and show IP route. Okay, right, so we'll see 2.0 and 1.0. Now will it work? So let's wait for this amber to become green. That means they're still communicating, and they're going to see what's going to happen. Right, now will it work? Fingers crossed. Let's see what happens. Timed out. Absolutely yes, it is going to work because it sent this IP a packet here. It's did an ARP 192.168.1.1, which is this interface. This interface sends its MAC address. Then it sends that whatever that ping data to this router. This router knows that 2. Is connected to its G0/1 interface, so it sends out on that interface, and it finally finds this IP address 192.168.2.10. But this is an overkill because you are wasting 2 interfaces of this router. You could do this with 1 interface. So what are we going to do is do the solution that is the ideal solution, right? That is to kill this and have only one where you're not wasting an interface of the router. So F0/1 should become a trunk now. So we're going to go back here and configure T interface F0/1 switch port mode trunk, right? So now this is a trunk. I mean, we don't need to make, we're not going to use F0/4, so I'm going to just let it be in VLAN 20. It's not going to harm us. What else? So now we can go show interface trunk. We see that F0/1 is trunk. It's doing 802.1q encapsulation, and it's trunking. All right, so like I said, now we only have the 802.1q encapsulation, so which is fine. Earlier, if you want to do a trunk, you need to give that encapsulation switch port trunk switch port trunk encapsulation .1q. You had to give a command, but I think nowadays you don't have to give that command. Right, so this is a trunk. So we'll quickly look at the VLANs as well. Show VLAN, and we see that 02 is in 10, 03 is in 20, and then 01 is a trunk. Now in this case, G0/1, that's what, G0/0 is a is where this is connected. So first I'm gonna go and change interface G0/0, and I say no IP address, which is removing the IP address. So there's no IP address in this interface now. But this interface is I've done a no shut on this, so this interface is now not in a shutdown state. So that means it's running. Right now, what IP address do I give here? Do I have to remember earlier we had two interfaces, so we could give one interface in 192.168.1, which is connected to this VLAN, and the other one we gave 2.1 for this network. Now this is a trunk. That means both the traffic coming from 1.0, 1.10 network and 2.10 network, both of those traffic will go out of here. But this interface, what IP address do you give to that interface? Right, something to think about. That is why we don't give any IP address in this network. In this interface. So G0/0, the physical interface, there's no IP address. So what do? So we come back here. We do. There's a concept called as sub interfaces. So we will say interface G0/0, right? G0/0, and you'll see that the possible thing is a slash or a dot. When you say slash, that means sometimes when you have more modules, you'll have /G0/0/0, which is like module counts, or you have dot. So what is dot? Dot is when you have sub interfaces. So I'm going to go put a question mark here, and it says you can create 0 to, what is this number? 4 million, or 4, is it 4 billion? Yeah, 4.2 billion. Whatever the number is, so many sub interfaces can be created, right? Or rather, so many, you can give the interface number, right? That's a number that you're going to put. So I'm going to put a number. I'm going to put number 10 to signify it has it. I'm going to put number 10 so it signifies VLAN 10. Right, so now we have gone into a sub interface. You'll see this command, it has changed to sub interface. What's a sub interface? G0/0.10. Now I'm going to treat this sub interface. Now technically we are creating two sub interfaces, and you're going to practically treat it as a physical interface, just like how we did earlier. Now we are going to treat this as connected to this network. So here I'm going to give the IP address 192.168.1.1.255.255.255.0, exactly the same IP address. So before you put this IP address, you need to do encapsulation. So we did encapsulation. I told you that this trunk is acting on an encapsulation, or it's doing encapsulation using .1q. Now here we did a sub interface, and sub interface needs to know if what encapsulation is it using. Is it using .1q or is it using ISL, right? So we need to do this command encapsulation, right? We're telling encapsulation. At the moment there's only .1q, so it's a command that is not technically required, but it still needs to be added here. So we're telling do a .1q encapsulation, but the reason this command is there is because it needs to know what VLAN it should work on. Now .1q is an encapsulation that talks about VLANs, right? Now a router is suddenly starting to act like a switch. It starts learning about VLAN tagging, right? So we're telling all the traffic to be encapsulated with a .1q encapsulation, and this has to be part of VLAN 10. So we need to give the number of the VLAN. So it is VLAN 10. We are going to say VLAN 10. Right now it will let us put an IP address 192.168.1.1 255.255.255.0, and it is working. Right, similarly interface G0/0.20, right? So I've just created a new sub interface, and you see that the command has changed to sub interface. Again, we need to do an encapsulation, so encapsulation .1q, and what VLAN are we going to work on now? It is going to be VLAN 20. Now put an IP address 192.168.2, right, 2.1 255.255.255.0. right. So you see that this is because we had earlier configured, so we need to first go remove that. It will not let you put an IP address because obviously you'll have a conflict of interest, right? You have two, you have a sub interface and you have a physical interface on the same IP address. So I'm going to go remove that IP address. Interface G0/1, no IP address, right? No IP address, right? And I'm going to shut down this interface because that's not required. Now if I go back, interface G0/0.20, right, and I will put that IP address 2.1, and it is all working now. Now show IP route, right? So if you can see, 192.168.1.0 is connected to interface gigabit Ethernet 0/0.10, and 192.168.2.0 is connected to gigabit Ethernet 0/0.20. right? This is perfectly fine. Now we go here and we do the same thing. We try to ping. Will it work? Right? So it's sending the traffic here. It's going to go through the trunk. It's going to this router. The router is going to look at that interface. It's going to send out on that other interface, and it should ideally come here. Yes, it started coming. It failed twice. That's ARP failure. ARP is just going to take some time. Once ARP finished resoluting it to an IP address and a MAC address, it started working. Right, so I think that's how you do, and this concept is known as a router on a stick. Right, so thank you so much for watching. I know there've been a lot of topics that we discussed in this video, so I request you to watch it again if you've still not got the concepts. Watch it a few times, because once you watch it over and over again, and then like I said, practice. CCNA is not a theory exam. CCNA is a practical exam, so you need to have practice. The more you practice, the more you're going to learn things, and whenever you learn something, just take a notebook and start jotting down in your own words of what you learned, right? Even when you're watching this video, I would say whatever I'm going to say, just jot it down in your own words in your notebook, and that is the notebook that you should be referring over a period of time. Whenever you're going to revise whatever you have learned, just refer to that book, and over a period of time you will become a champion of the topics of this technology, right? So thank you so much, and we're going to see you in the next video soon. Bye bye.